Hello everyone. So today I'm going to talk about periodic trends and all the details that you need to know for the MCAT. So in order to understand all of the other trends for the periodic table, we need to understand what the effective nuclear charge is. So the effective nuclear charge is basically the force of the protons on the valence shell of electrons that are on the furthest layer from the nucleus. As we move from the left to the right side of the periodic table, we are not really adding any more layers of electrons, but we are adding more and more protons as we move to the right. So the effective nuclear charge is going to increase. And as we are moving that way, because of the number of protons that is increasing, we are going to pull the electrons closer and closer. And by knowing how the effective nuclear charge is affecting the atom shape, we can kind of explain each and every periodic trend without even memorizing. So the second periodic trend that I need to talk about is the atomic radius. And knowing the effective nuclear charge makes this really easy to understand because we know as we are moving down the groups, we are adding more and more layers. So the atomic radius is going to increase. And also, as we are moving to the right side of the period, we are adding more and more protons, which are going to pull in the electronic layers, making the whole atom smaller and smaller. So the atomic radius is going to increase as we move down and also decrease as we move right in the periodic table. The next periodic trend that I want to talk about is electron affinity, which is basically the energy that is released when an atom gains an electron. Now, one thing about the electron affinity that is a bit counterintuitive is that as it increases, it becomes more negative. So, the trend for electron affinity is kind of similar to electronegativity because it's both about gaining electrons. So as we move right in the periodic table, we're going to increase the electron affinity, making the number more negative. And the element that has the highest electron affinity or the biggest negative number is going to be fluorine here, which is also the element who has the highest electronegativity. And as we move down the periods, because the layers are getting... So ionization energy is the other periodic trend that I want to talk about. So the next periodic trend that we're going to go over is the ionization energy. And ionization energy is basically the energy that we need to take an electron from an atom. And as you know, the only thing that's going to stop you is the positive charge from the nucleus. So as the radius is going to increase, the ionization energy is going to decrease because we get further and further from that positive charge. So we kind of can know that the ionization energy is the reverse of the size of the atomic radius. So as we move down, the ionization energy is going to decrease. And as we move right through a period, we know that the radius of the atom is going to decrease, increasing the force of the nuclear charge on the electrons, which is in fact going to increase the ionization energy. So the next two periodic trends that I want to talk about. So these two are the next periodic trends that I'm going to talk about, and the reason I put them together here is that they're kind of the reverse of each other. So we know that the electronegativity is the tendency of an atom to pull electrons in a bond. And the trend for that is that as you go up and right in the periodic table, it's going to increase. And fluorine, which is the top halogen, has the highest electronegativity on the periodic table. Now, metallic character is basically the reverse of that, which is the tendency of an atom to lose an electron. We can also attach the metallic character to ionization energy and saying that as the ionization energy decreases, which makes it easier for us to take an electron, the metallic character is going to increase. So if we reverse these two, we are having the trend for the metallic character, and it increases as you move down and you go left in the periodic table. And the atom that has the highest metallic character is going to be francium. So ionic radius is the next thing that I want to talk about in the periodic trends. And well, we all know that if we have like calcium and then we turn it into the calcium ion, it's going to lose some of the radius because we took 2 electrons out of it. But the thing that I want to talk about today is basically the isoelectric atoms, which are the ions that are all going to end up like the noble gas in their period. So for instance, if we go for neon, in that period, we're going to have fluorine and also oxygen that can get to it by gaining electrons. And on the other hand, we have sodium and magnesium and also aluminum that can get to the configuration of the neon by losing electrons. So the way the isoelectric atom's radius changes is that, as you can see, the common thing about all of these atoms is that they have the same number of electrons, but the difference is in their proton numbers. And as you know, as we are moving this way, the proton number is increasing, meaning that the effective nuclear charge is also increasing. And as we know these two facts, we know that the radius is going to decrease as we move through the positive ions because they have the same number of electrons, but the nuclear charge is strong. So if we want to rank these for their radius, it's going to be something like this. So the last thing that I just wanted to talk about in this video is the shielding effect, which is basically the opposite force that the electrons on the inner subshells have on the pull of the positive nuclear charge. And as we go down a group, because we are adding more and more layers, this shielding effect is going to increase. And this is also the reason that the effective nuclear charge that I talked about in the beginning of this video doesn't change as you move down the groups, but it changes in the period. And the reason for that is that as we go right in the period, we are not really adding any more layers, meaning the shielding effect is constant, while we are increasing the number of protons, which is going to increase the pulling force, shortening the radius of the atom. I just wanted to put this in the end of the video because I think this is really important to understand the effective nuclear charge. And also the effective nuclear charge is really the baseline of understanding all the other periodic trends.